So for the egg lab, you were here Friday. You saw all of our setup, how we put the eggs in vinegar to dissolve the shells. And just as a reminder, that was not part of the part of what we were testing for. We knew what was going to happen when we put the eggs in the vinegar, um, and that's why we did it, because we wanted to dissolve those shells. So when we did dissolve the shells, we noticed yesterday that the eggs were rubbery, almost like a water balloon, because the shell had dissolved all the way off, but the membrane was still intact. And so they were still whole, but they had that soft texture, kind of like a firm water balloon, basically, is how the students described it. Um, so we put one egg in a beaker full of Karo syrup. We put another of the eggs in a beaker full of water. Left them overnight. What's going to happen? Um, one of the eggs, the one in water, well, here it is. Ooh, you can see it too. It's all yellow, huh? It's lost that shell. Um, it gained mass. We took the mass again, and it gained about 2 grams of mass, which is noticeable. It doesn't look a lot bigger. It doesn't feel, any fuller or firmer. But it gained about 2 grams of mass. The other egg, you may be able to even see too, it lost quite a bit of mass. Um, and this one's actually been sitting in water again a little bit, so it's increased. But the other egg lost about 30, no, I'm sorry, yeah, about 30 grams. 30 grams decrease in mass. So this was the egg that was in the Karo syrup, and it lost 30 grams of mass. The other egg in water, it gained about 2 grams of mass. And the questions that I was asking the class, it's what happened? What happened? Why did the egg in the water increase in mass? Why did the egg in the Karo syrup decrease in mass? I drew a couple diagrams on the board as students were explaining it, showing the possible movement of water molecules, which is a big hint. Water molecules were moving. Um, but I erased them. I don't have them anymore, and I don't know how to show you a picture on the video. You pause the video. You see if you can come up with a great idea of what happened, and then I'll explain it to you. So pause it now. Okay, you've probably unpaused it by now. Or if you haven't paused it yet, pause it. And if you're unpausing it, perfect. Were you right? What was your explanation? So the egg in the Karo syrup was placed into an environment where the concentration of water was a lot higher inside of the egg than it was outside of the egg. Eggs do have a little bit of water in them, just like we have water in us. Eggs have water in them. So why it shrunk was the concentration of water outside of the egg was a lot lower. And we know that through the process of osmosis, water molecules will move from an area of higher concentration to an area of lower concentration across a membrane. So the water that was in the egg moved out of the egg to try to equalize the concentrations of water, both in the egg and outside of the egg, so that it was equal all around. The egg that was in the water, the opposite happened. Yeah, there was water in the egg, but there's also a lot of other stuff in the egg. And when it was placed in the tap water had a higher concentration of water than the egg did. So it moved into the egg through the process of osmosis, going from that area of higher concentration to an area of lower concentration. And that's why the egg increased in mass. One of the questions that I asked all the students was, why then did the egg in the Karo syrup lose so much mass? It lost a lot of mass. I think in some of my classes it was about 40%. But the egg that was put into the water, it only gained a little bit of mass. I think in some of my classes it was like between 1 and 2%. Why might that happen? I don't have an answer for you. Just, something to think about. Haley, answer whatever questions you can on the analysis questions. Go ahead and think through those. If you're up to it, write a conclusion. And again, if you have any questions, let me know. Hope it was helpful, and hope to see you back soon.